When I was little, I used to play a game with the moon. I would get into my car, strap into the booster seat, and look out the window. On a clear night, I would see it and know that it was following me. So I kept my gaze on it, never blinking, fearing it would just jump ahead of me and win this imaginary race that had no prize. And we would get home, and I would bolt into the garage, satisfied I had won, which I just assumed was because a giant celestial body wasn't crushing my house. But as I grew older, I realized that the moon wasn't following me literally, but figuratively, along with the rest of the universe behind it. Quite early on, I developed an interest in space. I loved learning about how light is not instantaneous, and about how time passes differently depending on the strength of gravitational fields, and about the scarily huge objects that exist out there, and about how we might never escape our own galaxy, and about how the inevitable heat death of the universe will eventually end our existence, leaving the world as a cold, black slate, empty of everything. Sounds fun, right? But as a child, learning these things, I was understandably scared. I worried that nothing in life had meaning, and was convinced there was no point in our existence. But in an odd way, that became freeing. Because by constantly thinking about these topics, I developed a perspective in which the terrifying and inconceivable nature of space became a teacher for how I should live my life. And that's what I'm here to share. A high school student's philosophy based on lessons from the universe. Lesson 1. Our life deficits, guilt, and bad memories don't matter. The things in the universe are obviously big. Our own sun is 864,000 miles in diameter, meaning it could fit approximately 1.3 million Earths inside. Now already that sounds huge, but in reality it's just a speck compared to some of the behemoths that lie out there. Take Stephenson 218, for example, the largest star we know of. If it were placed in the center of our solar system, it would engulf the orbit of Saturn. Now, stars like these are incredibly impressive, but they're also very inefficient. They burn off their fuel quickly, die in a brilliant supernova, and can sometimes leave behind a black hole. Given time, these creatures can grow absolutely massive. Take Sagittarius A, for example, the black hole in the center of our Milky Way. It has a mass of 4.31 million times that of our sun. Now, once again, that sounds huge, but it's basically a dot compared to some of its siblings. Ton 618, the largest black hole we know of, has a mass of 66 billion times that of our sun. Its body is so huge that it spans the entire solar system, 11 times over. But you wouldn't even notice Ton 618 against the backdrop of the galaxy. Our own Milky Way is 100,000 light years in diameter, meaning it takes light, the fastest thing we know of, 100,000 years to travel across it. And once these galaxies are continuously grouped together, we reach the largest structure known of, the Hercules Corona Borealis Great Wall, estimated to be 10 billion light years in length. It's so huge that it surpasses the maximum size allowed by the current model of the universe's expansion. At this point, we've reached the size limits of the universe. Now, do those numbers make you feel small? Well, they should have. And here's why. Our life deficits, guilt, and bad memories mean nothing against that backdrop. To illustrate this, let's say you get a bad grade, something high school students are all too familiar with. Sure, it's disappointing, and sure, it's a mark on your record, but what do you think the universe makes of that event? Nothing. It has no importance compared to the magnitude and significance of what goes on out there. And I say that not to downplay your struggles, but to lift the weight off them. Raising your grade will be tough. You'll be staying after class, trying to get extra help, all the while balancing extra commitments. Stress should play no part in that situation, which is why you should look to the universe. Because when you think about the red hypergiants out there burning away their fuel before exploding, when you think about the black holes feeding and growing past the dimensions of our solar system, when you think about the galaxies that house these behemoths and stand even larger, when you think about a structure so large that defies the understanding of our universe, you can't help but feel the pressure dissolve. By seeing a large scale out there, we can create a small scale down here and eliminate sources of pressure, discomfort, and unhappiness, because in the grand scheme of things, they're insignificant. Lesson 2, count your blessings, we are lucky. Something arguably more absurd than the universe's sense of size is its sense of time. Within 10 to the power of minus 32 seconds after the Big Bang, the universe had expanded by a factor of 10 to the 26th, an event adequately named the inflationary period. For the next few seconds, the first fundamental forces began taking shape. First gravity, then the strong nuclear force, followed by the weak and electromagnetic. For the next 500,000 years, the universe started to cool down from the unfathomably hot soup it was. And by 1 billion years, conditions were finally ripe for the first stars to begin forming. At 5 billion years, our own solar system began taking shape. The Earth, the Sun, and all of our planets and asteroids began forming from a revolving disk of dust and debris. 3.7 billion years ago, the first life forms on Earth started to emerge, beginning a cycle of evolution and mass extinction. 200,000 years ago, the first modern humans appeared and continued to evolve until this point today. 10 billion years from now, our own sun will die and end its life as a white dwarf. In 100 billion years, the galaxies that we see when we look up at night will start to disappear behind our line of sight as the universe's expansion overcomes gravity. In 10 to the power of 14th years, the degenerate era will begin. Here, galaxies lack sufficient gas to initiate star formation. The universe's lights will start to dim. In 10 to the power of 45 years, the black hole era will begin. Now, the only thing left are black holes floating through the universe, slowly evaporating away. And in 10 to the power of 100 years, the dark era will begin and last until the end of time. Now, the only thing left are electrons, positrons, and neutrinos swimming through an empty sea of black. Now, this is depressing. I'll be the first to admit that. But there's something so soul-crushing about how nothing will be our future forever. But here's the thing. 10 to the power of 100 years is such an incredibly colossal amount of time that comprehending its size is essentially impossible. The fact that we predicted the dark era exists makes no difference whatsoever. It's highly improbable we'll live that long, and even if we do, we'll have different standards of living by then. So why focus on something so far ahead when we can focus on what's happening now? One reason I've heard is that we're the victims of a cruel joke. We learned about the universe's existence only to discover that it'll die, along with everything inside of it. I counter that by saying that we've been given a gift. We look up at night and we see brilliant images of supernovae, planetary nebulae, plasma jets, galaxies, and even black holes, the things we're not supposed to look at. Based on the projected path of the universe, the span of time that these objects should exist for is inconceivably small, and we happen to exist at that same moment. So how then can one say that we're the victim? The fact of the matter is that we're lucky, so we should count our blessings. Lesson 3. Find fascination in the things that lie in front of us. The distances between objects in our universe is huge. So huge, in fact, that the maximum distance humanity can reach out into space is smaller than you might think. Let's start with the sun. It's 8 light minutes from Earth, meaning it takes light 8 minutes to travel in between. If we extend that to the closest star to us, Proxima Centauri, that distance becomes 4.2 light years. Now already that is an incredibly hard distance to cross, but it just keeps getting worse from there on out. Between the Milky Way and Andromeda, we would have to cross 2.5 million light years. If we extend that to the entirety of our local cluster of home galaxies, we would have to cross 10 million light years. Now the local group is part of a larger group of galaxies, known as the Virgo supercluster. If we wanted to cross that, we would have to cross 55 million light years. And then we can group the Virgo supercluster into the Laniakea supercluster, and that becomes 500 million light years. Now if you remember, we had trouble even crossing the distance between our sun and the closest star. So the possibility of us reaching other intergalactic groups, let alone the edge of our own Milky Way, is inconceivably small. And as if that wasn't bad enough, we have to deal with the fact that the universe is expanding at an accelerating rate. That means those destinations are being pushed away from us. Now, at a smaller scale, such as within our own local group, that doesn't really matter, as gravity will win out against the universe's expansion. However, it makes travel between intergalactic groups incredibly difficult. It's almost like me trying to catch up to a car by walking at a snail's pace. It'll never happen. Basically, we're stuck here. Now, even though we know that crossing these distances is science fiction, a part of us still believes that we can accomplish these feats. And perhaps that's the reason why the fact that we may never reach some of these destinations is so upsetting. It goes against our imagination. As children, we were all taught that we have no limits, but as it turns out, we clearly do. But instead of seeing these barriers as enemies, we should look at them as an opportunity to zoom in on a smaller picture. Focusing on just our own galaxy yields between 100 to 400 billion stars. Within our own solar system, we have planets that cover all sizes, moons that have subsurface oceans, asteroid belts with rich metals, and so much more. On Earth alone, we have miles of forestry, canyons, rivers, mountains, waterfalls, etc. And as it is, we're still uncovering mysteries within arm's reach, such as about the moon, the Earth's core, and even our oceans, 80% of which are still unexplored. There are so many things to dive into, and the fact that we can't go beyond them shouldn't deter us. Instead, we should see these barriers as an opportunity to zoom in on a smaller picture and appreciate what lies in front of us. So by this point, you've either started to view the scary parts of the universe in a positive light, or you're even more scared by them. Either way, what I hope you see is that the universe can be eye-opening. Its size may be intimidating, but use that to lift pressure off of yourself. And with its bleak future, use it to appreciate how lucky we are to live now. And with the seemingly discouraging distance of space, use it to find fascination in the things that lie in front of us. For me, reaching these realizations started when I played games with the moon. But for you all, it can start as soon as you leave this room, if you see the universe as a teacher. Look for the philosophy it has to offer, and I guarantee you'll gain a new, possibly better outlook on life.